is interested in this topic? Okay, good start. Great. I just want to look because I'm here for you in a small group. I can change topic if you want. I can talk about anything. Okay, so you're interested in the topic. That's great. Why are you interested in the topic? So who is doing work on it? Just so I understand. Okay, so a few people are doing work on it. A few people are who is planning to do work on it. Okay, the people who are not doing work on it, why are you interested?
What's IoT stand for?
I think. Okay, I don't know. Questions at the end.
Okay.
Questions at the end. Yeah, sorry. So if you're not actually doing work on mobile apps for IoT, so you're here because you're doing hardware. Who is doing hardware? Hardware? Okay. So some people are doing hardware, some people are doing apps. So it's useful for me to understand your background. Okay. So I will share my advice based on my own experience with my company on developing apps for IoT. So of course, as an initial slide, we can talk about the process of starting from an idea and then thinking in detail about the design for your mobile app, and then once the design is confirmed and it embodies the idea, you move over to the implementation. This never happens. Yes? So this is really not the way apps are developed in IoT. A linear process. I don't know if you ever saw this in IoT. Yeah, I will buy you a drink until you tell me where you saw it, because I never saw it. I saw it in pure software development. You should really work hard for it. But in IoT, I never saw it. So what is the why? Why do you never see that? All right. Well, it's complex. IoT is complex because there's a lot of sources creating complexity, and we will look into that. To look into that, let me start from my suggestions on how to plan your work. So, why IoT project is complex? First of all, there are a lot of components in an IoT project. There is the circuit board, there is the firmware software inside the board, there is the software outside that controls it, like mobile app. There is the other hardware around the PCB. So it could be glass, metal, the enclosure. So there's already 4 components: the enclosure, the PCB, the firmware, the software, and all those multiple components are developed by separate teams. You cannot expect one team to know how to make glass, how to make mobile apps, right? So you're going to have probably 4 teams, at least 3 teams working on the same product. Often those teams are in multiple locations because you would have, say, a mobile app team in Hong Kong, the firmware team in Shenzhen, say the team developing the enclosure is probably not in Shenzhen or Guangzhou for the different locations in mainland China. Because of this, we also have multiple timelines. Often the simpler hardware parts are developed before the PCB, which is developed before the firmware or parallel, often before the app. Often the app comes at the end, but it has implications of how everything develops. So there's because we have this variety of components, we have a variety of timelines that don't start at the same time, don't end at the same time, they need to coexist somehow. And this creates a huge complexity. And this is where the root of the complexity of IoT projects are. Do you recognize this? Have you seen it a few times? Yeah, it seems you have. So IoT projects are complex. If you've never seen this complexity, I hope you understand the root of it now. And how can you deal with it? Well, there's a few tips on what you can sort out early. There's a few things you should sort out early. And they have nothing to do with hardware, PCB, software. They are much more basic. Communication. If you have 4 teams working on your product, how will they communicate with each other? How does does prioritization work? Who chooses what is done first? Is there someone who chooses what is done first? Oh, by the way, I can send the slides afterwards. So yeah, in case you're doing a photo for the slides, I can definitely send it to you if you send me an email later. And yes, so communication, prioritization. Alongside prioritization is about decision. Who will make a decision for the software, for the PCB, and it's not so simple to decide who will make a decision on each of those things, because to make a good knowledgeable decision, you need to know some details, and no one person will be able to know all the details of an IoT project ever. It's just too complex because there are multiple teams, and so there's not going to be one person responsible for every decision. Which brings us to the next thing to sort out early. What can you and should you delegate? What decision does the main person, the main client, the person responsible for everything, what decisions does that person need to keep, and what decisions do they need to delegate to other people? And yeah, this is my short list of things to sort out early. If you make these decisions, then you set up a good set of work routines for your different teams, and that can help avoid issues. Okay, so once this is sorted out, you can actually try and start with the design phase. Here I will talk about design of the mobile app or server, so the software design. What do you typically try and do during a design phase for IoT? You have a big list of features because your new hardware is typically very powerful, can do lots of things. But all these huge list of features needs to be packed into a small controller, a small remote control that will be able to tell your hardware how to behave. But here's a question for you. Mobile app that you are designing and creating, is it a controller? Is it a remote control? Let's take a look. So I'm going to show you a few examples of mobile apps, and we're going to look whether they are or are not controllers. So what I did is I took a look at the mobile apps I've got in my own phone for some common products that I use at home or in the office. So this one is Bose, a sound equipment company. I think many of you will know it. I have a pair of headphones, and there's a mobile app that helps connect those headphones with the mobile phone or other, the iPad and laptop. So, okay. That's what this app does. It's definitely a controller. It controls how it helps me decide how my headphones will behave. Then, okay, I've got the air purifier from Xiaomi. So I've got the Mi Home app. It tells me what the air purifier sees in terms of air quality, and it allows me to switch it on, off, program it, night mode, silent, etc. So again, this is a controller. And this is another example. This is actually a mobile app that we developed for a client of ours called Tito. Tito is a light. It's an LED cube, so it's 8 by 8 by 8 LED lights. And this light plays animations. So this cube can play all sort of animations, drawings, all the simple cars. And yeah, you can choose it from mobile app, whether there's a lamp or colors, whether it's playing some emojis, etc. Okay, so this is also a controller. But it needs to be a little bit more, because with this app you can also send emojis, not message emojis, but light emojis to other people. So it starts to be a bit more than just a controller. It does some messaging features. And of course you can design your own animations, so that's again above what a controller does. Another product, Untitled. Untitled spoke at Hardware Massive a few months ago. Untitled is a controller, or the hardware device is a controller for your air conditioner. It's kind of like the US Nest. Nest controls central heating, and in the US, where we need a lot of heating, here we need a lot of air conditioning, and Amitrana controls your air conditioner. So it's a small object like this. You put it in front of your air conditioner, it sends some infrared signal, just like your air conditioner remote controller would, but it does it from this device, so you don't have to. It means you can control it from a mobile app. But is this just a replacement for the remote control? Is it really a controller? Actually, here it clearly is not. Because the point of giving control of your air conditioner to ambient climate is that you don't have to tell it when you want the air conditioner to go more, less, when it's too cold, too hot. So in fact, this app is actually an artificial intelligence trainer for your device. So in this app, you don't tell it higher air conditioner, lower air conditioner. This app asks you, are you comfortable, or are you a bit warm, or are you a bit cold, very warm, very cold? So you tell the app how you're feeling. And then the app learns, you're feeling too cold, so I should now, of course, adjust the air conditioner, but also I should remember in the future that around this time, on a weekday or weekend, normally the temperature and humidity combination should be like this rather than different. So actually this goes much beyond the controller, because yes, at the beginning, when the hardware device is not trained, where the AI component of the hardware device is not trained, yes, it's a controller, but it's also training the device, and the objective is to have to be able to use less and less the controller. And yeah, so this is really not a controller. It looks like one, but it's a controller that is disappearing, that you no longer need to use. Next example, again from both. This one was controlling my headphones. This one is controlling some speakers that I have in the living room. So yes, I can switch on and switch off the speakers. So in that sense, it's a controller. But there's a lot more. For example, I can bring in playlists from Spotify into this app. So yeah, it brings in a lot more information than a normal remote control would. It's a very rich type of controller. Right. And then I've got my sixth example. And this app really is way more than a controller. It's a very simple app. I thought so. I thought it was before I started looking into it. And I realized the complexity and how different it is from other apps. But before I show you my favorite, not a controller app, I wanted to ask you, do you have any examples that you'd like to share of IoT apps that are not a remote control? Or are they mostly remote controls in your experience, which is also mine, actually? Any example, or should I show the sixth one?
The circle one that, like, it looks like a circle that in the app there's a ring that you can slide and change the graphic to the direction of the graphic, something like that, or change the screen by swiping left and right.
Okay. What is the hardware product? What is the related hardware product?
The hardware problem is how to program it. How to program it, they slide from left and right. When it's doing it in the rain.
What is it?
Do you remember the name?
I do not have a name. It's just we have to we have to create a UI that looks like a rain, and then we do not know how to program when we slide these sorts of things. This is a kind of controller that the problem we have encountered before.
Okay.
Because the client asks us to like, we have to design an app that with a range, so people can swipe it from to the left and to the right as well.
Okay. Yeah, I never saw the type of.
Yeah, and it's still very difficult for us like students to program it.
Okay. Thank you. Thanks for sharing. Well, my next example is a bit surprising. You all know it. It's the Fitbit app. And yes, of course, the Fitbit app controls my Fitbit watch. But really, when I started to think about it a bit deeply, I realized how much not a controller it is. For example, let us look at my usage. So, I got my app, and it is connected to my Fitbit Blaze. It's connected to a smart scale I have at home. It's connected to a cup that measures water or liquid I drink. Yeah, because you can go that far with IoT. And it's connected to a mobile app where I can input the meals I eat for nutrition and calorie tracking. So, first of all, you see, this one is not, yeah, of course you can set some functionality here and there. It is connected to several devices. And let us look at the interface. It's actually, okay, this is the main dashboard. So it's a dashboard app. It tells me what I've done, in terms of movement today, how I slept, how often I exercised this week so far, my current heartbeat rate, my resting heart rate, and how much water I drink. There's more information later. And then of course, yeah, more on swimming and more on exercising weekly, etc. So this is not about controlling this watch. This is really about having a view of my own self from all the devices that I use, that I choose to use, and that connect to a single dashboard. So this is, truly, if you compare, say, this to this, it's completely different. You have this functionality, you have it here, but this one goes beyond the single device, and tells you so much more. So why were we talking about these differences between these different apps? Because, well, when you start to design and develop a mobile app, you need to understand and decide what it is for. Is it a controller, or is it not a controller? And therefore understand what you're going to do with it. What you're going to do, how you're going to plan the design of the mobile app. Okay, so yeah, of course the challenges in the design phase is that you need to pack a lot of features in the same single app. And when you pack a lot of features, you end up having something that's not very clear. So to maintain simplicity, you may need to prioritize, highlight some specific features and minimize others. So my tips for achieving that. Well, the design of the UI, of the interaction needs to be consistent, meaning within the app it needs to be a consistent language that the user will not get confused by, because it's the same language. You need to remember that this app doesn't exist on its own. It exists in relation with the device or devices that it is connected to. So, knowing the system status, is the app connected to the device or is the app not connected, is important because the app will behave differently whether it is or it is not connected, and that should be visible. And in relation to that, well, you will have a different behavior of the app and also of the hardware device, whether app and device are connected. You should be able to use the app when it is not connected to the hardware device. For example, for its maybe dashboard features. You should be able to use the hardware when it is not connected to the app. For example, I can walk to my Bose speakers even without taking my phone out and still press on and play. So all those these are my tips for making sure that you keep simplicity in the app, remembering that the app and hardware are one, but they need to also exist separately. Okay, so that's for the design. Actually, the design phase is the most complex one in my opinion, because it is not just about it's not just about some drawings, it's about behavior, and it is typically done by both designers and software developers and people who understand the hardware all together. It's a very complex phase, it's done by a lot of people together. If the design phase is done properly, then implementation should follow relatively simply. But before we start on that, let me see if there are any questions on the design phase so far. Yeah.
Can you explain a little bit more about how Spotify app can control the experience? Just now you talked a little bit about Spotify.
No, sorry. So this app.
Yes.
So this app is this is not the Spotify app. This is the Bose app. Bose is a sound equipment company. So this app controls some loudspeakers. However, this app can bring in some features of Spotify into its app. So your question was?
What kind of specific features can the app change the Bose equipment?
Right. Okay. So specifically, this app can so once it is connected to a speaker, it can switch on, switch off the speaker, play certain preset playlists, change the volume. It can connect via Bluetooth if you don't want to connect via Wi-Fi. It can connect via the app. You can connect your speakers with online sources of music. So essentially, via the app, you connect Spotify with your physical speakers via Wi-Fi. So even when you don't have the app connected, you can still play Spotify or other online music sources. Directly. Yeah. Does it answer the question? Yeah. So yeah. So this is what the app brings to the speakers. Yeah, and it's a different experience because it's not just controlling what is in the speaker, but you also control what is on the internet to interact with the speaker. That's some of the complexity that we need here. Are there other questions on the design phase? Then development. So, how many here are programmers? Okay. A fewer than I thought. So, even if the design phase is very well set up, and you have very clear designs, very clear interaction, well sorted between the app and the firmware and the hardware, even then there are some complexities in the implementation phase. Let's look at that. So, first of all, when you start implementation, or in fact when you plan it even before, you probably want to understand what you have to work with and what do I mean by that. Is the hardware there? And this is not a trivial question, right? So, you might be working with you might be a software developer working with a company with a partner that does hardware, and you tell me, yeah, the hardware is there. And let's say the hardware is a light, and you expect to receive a light. What you receive is a circuit board with some maybe with some cables and that. So There are two different things. Of course, the circuit board could control the lights, but if the lights are not there, when you test things, it's a different experience. So, what is the hardware available? You can work either way, but you need to understand what is available. How about the firmware? Is it completely developed? Is it partly developed? Is it relatively stable? Is there documentation? Is the API? So the API is essentially the interface, so the function definitions of how the software inside the hardware, the firmware, interacts with the software outside of it. Yeah. So is the API well documented, well described? Is it all live, or is it just, let's say, mocked? Meaning, is it returning real data, or is it returning simulated data which is not fully implemented? Yeah, so is it implemented, is it documented, is it mocked? These are the things that you want to understand. What do we have before we start the software implementation? What do we have to work with? There's a hardware, firmware, and API documentation and implementation. Once you know what you have to work with, then you can try and figure out what you can do with it. Meaning, how far does the power, the potentiality of the hardware stretch? How far will they stretch? For example, what is the CPU inside the circuit board? How powerful is it? And as a result, how much API traffic can it handle? Depending on how many API calls your CPU can handle, then you will be able to decide how many calls to send to the hardware. Do you talk to the hardware often to check status, or less often? How do you limit it? How do you compress the information? Yeah, so the CPU power is very important to understand even the API behavior. It's important to know from the start. Then, okay, well, how many, if you ever work with a Wi-Fi module or a Bluetooth module, they're all different, they all have a different setup, configuration, documentation. It's all about the work. Yeah, you want to test it and then figure out how easy it is to set up. This stuff is just impossible to estimate. You have to try and do it and see how well it will work. And other hardware specifications. This is important to understand because of what you can do now, but also because of what you can do within 3 years' time. I mean, mostly I develop software, and I can build software every day if I want to. And mobile apps, web applications, servers that we work on, we can push an update immediately. It's immediately available to everybody. But once you design hardware, you're stuck with what you designed for, on average, let's say 3 years' time. Let's say that you design a product today, it takes you 1 year to bring it to market, and then before you bring the next version to market, it's going to be 2 other 2 years. So what you design today needs to be current for the coming 3 years. It's a very different type of horizon. And yeah, so this impacts software development as well, because you need to understand the potential future limitations of it. Wi-Fi module actually is a good example with the different frequencies. Okay, so challenges for software development in itself. Here we go back to what we were discussing earlier. We were discussing about the fact that there's multiple teams working together on different timelines. So you often have evolving specifications, which is natural. You need to be able to work with that. When you design a product, people see it in practice. And what you see in terms of design is very different from what you see on a list of specifications. You start to be able to interact with the product, you have more imagination about it, and so as a result, very naturally specifications will change there. And yeah, you need to be able to work with those evolving specs and prepare for it. Yeah, compatibility with the devices is very important. We mentioned Wi-Fi, Bluetooth, those are challenges for the development. And then again, parallel development, so the software of the mobile app changing at the same time as the software of the firmware and the API definition. It's something that is going to be worked on in parallel. How do you prepare to avoid some of these issues or to mitigate them at least? A couple of very simple tips. When you start to work on the software for on the mobile app for the hardware, ask the firmware and hardware team to set up over-the-air firmware update from the very start. It's a very simple thing, basically. Instead of having to involve the firmware team with cables and other stuff to update, having to disassemble the hardware, plug in a cable and update the firmware, you just enable by Bluetooth or by Wi-Fi the update of the software inside the hardware. This speeds up a lot software development because you can really it enables the app team and the firmware team to work more closely together, more in parallel. So OTA firmware update is very important to get earlier. And similarly for the API implementation, so the API might not be fully implemented when the mobile app starts being developed. Most likely it won't be, but if it is at least well documented, if there is an authentication set up for it, then again, you can work much faster together with two software teams for app and firmware. So the software side was faster compared to the design because the design part involves both software and design. But these were my software specific tips. That was my talk.